Let's take a look at empirical formulas. Empirical formulas are the smallest whole number ratio of atoms in a molecule. Typically, these are going to represent just the number and different types of atoms that are going to be present and does not correspond to all of the possible atoms in a molecule. Sometimes, though, the empirical formula is the molecular formula, and we see that with simple compounds such as H2O, but most of the time, empirical formulas are going to be a smaller representation of a larger molecule. Let's take a look at glucose. Glucose is C6H12O6. The empirical formula for glucose is C1H2O1. That means there are going to be 6 empirical formula units in the molecular formula of glucose. The empirical formula shows the ratio numbers of atoms in a molecule. When we look at a molecular formula, the molecular formula is going to be some multiple times the empirical formula. For the previous example that we saw of glucose, the empirical formula was C1H2O1. The molecular formula is going to be 6 times the empirical formula, which gives us C6H12O6 and allows us to find the information that we need for the number and types of atoms that are there based on the empirical formula. We have 2 different ways of determining empirical formula. The first one that we're going to look at is determining the empirical formula from the mass of atoms. In order to do this, we need to convert all atom masses to moles. Once we are in moles, we're going to divide by the smallest mole quantity to get a whole number ratio. At that point, we might have to round if we have anything that's greater than 0.05 away from the nearest whole number. Most of the time, though, the answers that you come up with will be straightforward and the rounding will be very clear. I will only have you multiply if it comes out to be 0.25, 0.33, 0.5, 0.66. These are multiples of 2, 4, and 3. So those are the only ones that you'll be looking for when you do your calculations. Finally, we have to write the empirical formula. We'll take the atoms that are present and write their whole number ratios as subscripts, as if we were writing any other type of formula unit. Let's take a look at this example. A compound consists of 2.25 grams of carbon, 0.568 grams of hydrogen, and 6.00 grams of oxygen. What is the empirical formula? Well, the first thing we're going to do is start by converting the grams of carbon into moles of carbon. So we take 2.25 grams of carbon, divide that by the 12.0 grams of carbon, and multiply by 1 mole of carbon to get 0.1875 moles of carbon. We don't know if this is the smallest moles of carbon, so we have to convert the other 2 first. So let's look at hydrogen next. 0.568 grams of hydrogen. The molar mass of hydrogen is 1 gram per mole. So we're going to multiply by 1 mole and divide by 1.008 grams of hydrogen. And that gives us 0.5635 moles of hydrogen. Finally, oxygen. Let's take the 6 grams and divide by 16.0 grams per mole, and that's going to give us 0.375 moles of oxygen. When we look at all of these moles, we see that the smallest mole quantity is that of carbon, 0.1875 moles. So let's go ahead and divide all of these units by the smallest moles. When we take 0.1875 and divide that by 0.1875, that's going to give us an equivalent ratio of 1. When we take hydrogen, the 0.5635 moles, and divide that by 0.1875 moles, we're going to get 3.005. Well, this number is close enough to 3, so we'll leave it as 3. We don't have to multiply by any multiple in order to get a whole number. Oxygen, we have 0.375 moles of oxygen. We're going to divide that by 0.1875 moles, and it's going to give us the ratio 2. So here we go. Our carbon is going to be 1, our hydrogens are going to be 3, and our oxygens are going to be 2. So we'll go ahead and write our empirical formula as C1H3O2. We didn't have to multiply by anything else because all of our values came out to be approximate their whole number. Now let's look at a more complicated way of determining the empirical formula. That would be from percent composition. In percent composition, we're given the percentages of all the atoms present in our molecule. And when you think about that, it's really difficult to deal with a percentage. It doesn't really correlate to a number. But if we assume that we have 100 grams of a substance, it's very simple to look at our percentages as being the reverse of our mass percent. And when we multiply by 100 grams of our substance, we can convert all of our percentages to grams of those atoms. Once we've converted to grams of the atoms, we need to convert to moles, and then we're going to follow the same procedure that we did previously, which is divide by the smallest mole quantity, do any multiplications that we need, and then write the formula for the empirical formula. So let's go ahead and start this off. Tear gas consists of 40.25% carbon, 6.19% hydrogen, 8.94% oxygen, and 44.62% bromine. What is the empirical formula? Well, the first thing we have to do is go through and convert all of our percentages to grams. So I'm going to take the 40.25% carbon, multiply it by 100 grams of the substance, and get 40.25 grams of carbon out. I'll do the same thing for hydrogen. 6.19% times 100 grams gives me 6.19 grams hydrogen. Oxygen's the same way. 8.94% oxygen now becomes 8.94 grams oxygen when we assume 100 grams of our substance. When we have 44.62% bromine and we multiply by 100 grams of our substance, we get 44.62 grams of bromine. Now comes the fun part. When we have all of our grams, we're going to convert every gram of our atoms to their moles. So we're going to use our molar masses. 40.25 grams of carbon divided by 12.0 grams per 1 mole of carbon gives me 3.354 moles of carbon. I do the same thing for hydrogen. 6.19 grams of hydrogen divided by 1.008 grams per mole of hydrogen gives me 6.141 moles of hydrogen. 8.94 grams of oxygen divided by 16.0 grams per mole is going to give me 0.5588 moles of oxygen. Finally, the 44.62 grams of bromine divided by 79.9 grams per mole of bromine is going to give me 0.5584 moles of bromine. Which here is the smallest? Well, that's going to be the 0.5584 moles of bromine. So I'm going to go through and divide all of these from top to bottom, all of these moles, by the 0.5584. Let's start with carbon. When I take the 3.354 moles of carbon divided by 0.5584 moles, I get 6.006. Well, like I said before, if it's not 0.25, 0.33, 0.5, or 0.66, you don't have to multiply, you just have to round. So here, 6.006 is going to be equal to 6. When we look at hydrogen, 6.141 moles of hydrogen divided by 0.5584 moles is going to give me 10.997. Let's go ahead and round that up to 11. When we look at oxygen, we're going to take 0.5588 moles of oxygen and divide it by 0.5584, and that's going to give us 1.001. In this case, we're just going to go ahead and round to 1. Finally, when I take the 0.5584 moles of bromine divided by 0.5584, I'm going to get 1. So my empirical formula for tear gas is going to be C6H11O1Br1. Again, we don't really need to indicate the ones, but when you're going through and doing this, it's just easier to show it. I'm not going to take off points if you show me a 1 in your equation when you do an empirical formula calculation on an exam or a quiz. Your book has a lot of good practice problems. So if you go to page 120 to 121, the mass percent, here's the questions that you can answer, and then the empirical formula, here's the ones that follow through with a lot of the stuff that we've done. So make sure you do these practice problems before you come into class and be prepared to ask any questions that you have.